Now let's talk about the Linux command line tools. Um, on the Ubuntu desktop environment, if you would like to access the command line tools, the most common way of doing that is by opening a terminal application. And if the terminal application is not on your launcher, you can go to the dash and just type terminal. And then you can just select the terminal application, which is going to open a terminal window. The terminal window has a menu bar inside of the panel. If you move your cursor, if you move your mouse to the panel, it's going to display the menu bar. This menu bar allows you to configure the look and the capability, the functionality of the terminal window. And as soon as you have opened the terminal application, you're going to get a terminal icon on the panel. If you would like to keep the icon in the launcher, you can just right click on the icon and then select Lock to Launcher. Inside the terminal, you're going to see your username on this particular machine, followed by the sign @ the @ symbol, and then followed by the name of the machine. In my case, the name of the machine is called Fresnel, and then followed by colon. The wiggle or tilde is a shorthand for representing the home directory of this particular user. And the $sign is the terminal prompt, so it's actually waiting for you to type in a particular command. If you would like to exit the terminal, you can just type exit, and it's going to close the terminal application. Since you already have the terminal icon, the terminal application icon embedded on the launcher, the next time if you want to launch terminal, you can just click on the launcher, and then it's going to open a terminal window for you. If you want to configure the behavior of the terminal, you can go to the menu bar and then select terminal in the drop-down menu, and then you can change the behavior of the terminal. For example, if you would like to change the profile, if you would like to set a title, set a character encoding, or change the size of the terminal. So this is how you can access the command line through a terminal application. The Linux command line is a self-documenting system, which means that you can easily find documentations of command line tools from within the command line itself. There are several commands that are useful for you to find the appropriate command line tools. The first one I'm going to introduce is called apropos. Suppose you would like to find command line tools that are related, for example, to disk partition. What I can do is to type apropos inside of the terminal, followed by the keyword that I'm looking for. So I do apropos partition, and then it's going to list all the different commands that are related somehow to partition. At this stage, for example, if you would like to look at fdisk in more detail, which means that so it's actually telling you fdisk is related to manipulate disk partition tables. So what you can do is to look into the type what is fdisk, for example, and then it will print out exactly the same information as it's being displayed by apropos. It's basically the first line in the manual page. And you can also try to find out where this particular command is located inside of your file system. So I type where is fdisk, then it's going to display it's stored under sbin, and then its manual page is stored under this particular directory. So if you would like to find out the detailed information about a particular command, what you can do now is to type man and look for the manual page of a particular command, for example fdisk, and then it's going to open the manual page of this particular command that you are looking for. And inside of this manual page, you can navigate through it by using the keyboard arrow key, up and down, one line at a time. Or you can use the keyboard page up and page down key, which will go up and down in like one page at a time. If you would like to go to a specific line, for example, if I wanted to go to line 50 of this manual page, I can just type on the keyboard 50 and then followed by the letter G. It will go directly to line 50 as being displayed under the in the information line at the bottom of the window. If I would like to go to a certain percentage of the whole document, suppose I want to go to a 50%, about half of the document, what I can do is to type a 50 and then followed by P, letter P. Then it will go to the 50%, around 50% of the document. So it's displaying that I have about 250 lines inside of this document, and I am at line 119, and it's also displaying the percentage. Suppose you would like to search for a particular keyword starting from the beginning of the manual page. What I can do is to type the slash in the keyboard and then followed by the keyword I'm looking for. Suppose I'm looking for partition, and then it will highlight all the different keywords inside of the all the occurrences of the keyword inside of the whole document. So suppose I want to jump to the next occurrence of the keyword, I can type slash again followed by enter. Then it's going to jump to the next occurrence. Suppose I would like to search a keyword from the end of the document or manual page, I can do question mark. Suppose I'm looking for a keyword called format. Then it will search from the end of the document backwards and look for all the occurrences of the format keyword. If I want to jump to the next occurrence, I type question mark and then enter again. Type question mark, enter again. So it will go backwards and highlight all the occurrences of format. If you would like to turn off the highlight, what you can do is to type the ESC key on the keyboard, followed by the letter U on the keyboard, and then it's going to turn off all the highlight of the keywords. Sometimes when you read the manual page, you would like to try out the different commands or different options of that commands in the shell, but you don't want to leave the manual page yet. So the manual page actually provides you a tool to jump to the shell right away. It's the exclamation mark. So if you on keyboard, if you type the exclamation mark and then followed by the command that I would like to try, for example, if I would like to try the list command ls followed by a certain option -l, I can type the command right away, and manual page is going to transfer it to the shell for you, and it's going to execute it and give you the result. So here's the result of running ls-l, and then its manual page is echoing done back to you and ask you to press return. So I'll press return. Then it's going to jump back to the manual page. So if you would like to quit manual page, you can just type Q on the keyboard. In addition to the manual page man command, you also have another command that's called info. If you would like to find some detailed information about a certain command, you can type info and then followed by the command name. And if you want to quit info, you can type Q. If you would like to find a detailed information about the info command itself, you can type info to find out how to use the info command. or you can do man info, which will give you the manual page of the info command. Of course, you can also do man, which will open the manual page of the man command itself. This is the self-documenting system, and you also have Google. Every time that you find something that you don't understand or you would like to search for something, you can always Google and find out the details. Now let's look at the ls command for listing the content of the current directory. The screen output, the screen display on my terminal shows that this is my username, followed by the symbol @ and then followed by the name of the machine, colon, and then wiggle is the shorthand for my home directory. The $sign is the prompt, meaning that the terminal is waiting for your input. So if I type ls, it's going to list the content of my current directory, which is my home directory. If you would like to see the ls coloring different content differently, you can use the option -- color. Then it's going to list the directories in dark blue and the ordinary files in white. If I do ls -- color, a certain subdirectory under work, and then another subdirectory, and then another subdirectory, you can use the tab key to complete the names of the directories. You will see that ordinary files are colored in white, ordinary text files, but executable files, the files that can be executed inside the terminal just like a command, are colored in green. So if you would like to keep the -- color option as a default behavior, what you can do is to define alias. You can define alias by using the alias command. You can define ls equals to, don't forget about the single quote sign, -- color. So now if you do ls, it's going to automatically list the content, the directories in blue and ordinary files in white. If you would like to see for a certain alias, if you would like to see the content of that particular alias, you can use the command type. We just define the alias ls. If you do type ls, it's going to list the content of the ls alias. It's telling you that ls is aliased to ls -- color. If you would like to see hidden files, you can use the -a option. It will list not just the ordinary files but also hidden files. In the Linux file system, any directory or file that starts with a name starting with a dot are hidden from the ordinary ls listing. Those files or directories, those hidden files or directories are usually associated with the configuration files generated by either applications or the system, and those files are not usually changed, so they are kept hidden from the ordinary ls command. But if you would like to see those hidden files, you can always use ls -a. Two of those hidden folders or hidden directories are of special interest. One is the dot directory. The other one is the -- directory. So dot directory is the shorthand for the current directory. So as you can see, I have under the current directory, I have a folder that's called public. I can list the content of the public by using ls public, or I can do ls -- which simply means I want to list the content of the current directory followed by, and the public is the subdirectory of the current directory. If I want to list the content of my parent directory, which is actually the directory that contains my current directory, I can do ls . It will list my parent directory, the content of my parent directory. Of course, my parent directory will contain my home directory, that's Potion, that's my current directory, and also a different directory called lost plus found. If I want to list the hidden files in my parent directory, I can do ls -a ... And then it will list the dot and the dot subdirectory in my parent directory. Of course, you can ask AOS to list all the hidden files excluding the dot and the dot folder by using -A. Then it's going to list the hidden files and folders under the current directory, excluding the dot and the dot folder. So if I would like to get more detailed information about each of the file or folder, I can do -AOS-A followed by -L. It's going to give me a long list of all the hidden files and folders with several different columns. The first column is going to display the permission associated with a particular file or folder. In the Linux file system, every file or folder has a permission. And the permission is actually displayed using this sequence of symbols. The second column, for directory, it actually displays the number of subdirectories inside of this particular directory. So for this .adobe hidden directory, it has 3 subdirectories, including the dot and the dot subfolders. And then the third column is the author or the username of the author who generated that file or directory. The fourth column is the group name for generating that particular directory. In the Linux operating system, the users or user accounts can be grouped into different groups, and each group will have a different name. And then the following column actually shows the size of a particular file or directory. A directory is also treated as a file, so it will have sizes, but we cannot confuse this particular size with the storage size of all the content inside of a certain directory. We'll look at the particular command for calculating the size of a certain folder, the storage size of a certain folder later on. And then followed by the last date or time where you made changes to a certain file or directory. The second column for a particular file, if it is not a directory, if it is an ordinary file, then the second column actually shows the number of links that's pointing to this particular file. We'll look at how to make links in a later command called ln, which will be discussed in a different video. All the rest of the columns have similar meanings as just the directory. For directory, in the permission column, the first letter is D. For an ordinary file, the first letter in the permission is a dash. A dash means this particular field is empty. If it's an empty field, then it means that it's just an ordinary file. There's also other symbols for the first letter in the permission field. Suppose I list the detailed information about a particular device, say TTY0. Then you will be able to see that the first letter in the permission is C, which means that this is a character device. A character device usually is a terminal. So TTY0 happens to be a terminal that will accept your command line inputs. Your command line inputs. If I list a different device, say SDB1, then the first letter in the permission field is B, which means that it's a block device. In the Linux operating system, a block device is usually a disk where you can write data onto it. So you can combine different commands together. If I want to do a long listing of all the hidden files excluding the dot and dot directory, I can just do one dash and then L and then capital A. It will have exactly the same effect. Or -L, -AL. So it doesn't really matter which letter comes first. If you would like to list a certain directory recursively, suppose I'll list my download directory. the content of my download directory. The download directory also contains subfolders. Those are colored in blue, deep blue. If I would like to recursively list all the content of the subdirectories of downloads, what I can do is to do ls-r followed by the name of the downloads. Then it's going to list the content of each of the subdirectories inside of the download, and also the subdirectories inside of those subdirectories. In fact, I actually have quite a lot of files underneath download, so I cannot actually scroll through them. So there is a shorthand. As you can see, I added a pipe followed by another command called more. So first it's listing the first level files and directories that's right underneath downloads. And then after it finished listing the first level files, it's going to go to one of the sublevels. So it's listing starting from here, it's actually listing downloads slash compact wireless, this particular subdirectory. So all those files in the following will be inside of that subdirectory. And then this subdirectory contains another subdirectory called compact, and then it's listing all the files inside of it. And then there's another subdirectory underneath compact. So it's actually going into every subdirectory inside of every subdirectory. If you would like to, the long listing automatically shows the size of the file or directory, which is displayed on the 5th column. But if you would like to just look at the size, you don't really need to list all the other columns. In this case, you can use the -s option, which will display the size in front of it, in front of every file or folder. If you would like to display those sizes in a human readable format, you can use the -h option. H actually means human readable. So instead of listing just the number, it's going to tell you the size, the unit of the size, for example 4K, which means 4 kilobytes, 12K means 12 kilobytes. Of course, you can also combine them together. Of course, you can also sort the output of AOS in a certain way by using the --sort option. Some of the commonly used sort options are size and time and extension. So if I would like to sort the files and the directories according to their sizes, I can do --sort size followed by L if I would like to have a long listing. And if I would like to have the size printed in human readable format, and it will sort the size. So the larger files, 8.8 kilobyte, is at the top, and then smaller files or folders following it. So the size is for folder or directory is not really the disk storage size of all the content of that particular folder. It's just the folder. It's just the size of the folder, not the size of all its content residing on the disk. We'll look at the command for obtaining the size, the storage size of a particular directory and its content in a later command called du, disk usage. But the size that's listed here are just for the folder itself. If you would like to reverse the order of the sort, you can use -r, and in this case it's going to list the smaller files or folders at the top and larger files or folders at the bottom. You can also sort according to time. So if you sort according to time, then the latest updates are going to be listed at the beginning, and the earlier updates are going to be listed at the bottom. If you would like to reverse this order, you can always use the R option. Then the earlier changed files are going to be listed on the top, and then the later changed files will be listed in the bottom. If you would like to list only the subdirectories under the current directory without listing all the ordinary files, what you can do is to do ls-d star then slash, and then it will list all the subdirectories under the current directory. And if you would like to have a long list, you can just do -aod or -dl star slash, and then it will give you detailed information or long list of all the subdirectories under the current directory. The same effect if you use dl. But don't forget about the star slash, otherwise you won't be able to get what you would like to have. The shell allows you to use what we call the wildcard. So you have two types of wildcard. One is star, the other one is the question mark. So suppose I would like to list the content of 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 the subdirectories which starts with do, capital case D, uh, small o, and then I can follow it by a star, and then it's gonna list the content of both the documents subdirectory and also the download subdirectory. So it's listing the documents subdirectory, and it has a number of subdirectories, and also the download subdirectory, which has both files and subdirectories. So star actually means that you have 0 or none, or any number of characters following the letters that you have typed. The same is true if you want to use question marks. Suppose because both download and document has 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. 1, 2, 3, 4, 5, 6, 7, 8, 9. Both of them have 9 characters. So what you can do is to do ls and then type 9 question marks, or type 7 question marks, and then it will give you exactly the same effect. So a question mark represents a single character. So what you're actually asking the shell to do is to list the content of any directory that starts with capital D and lowercase o followed by 7 characters or any characters. But the difference with lsdo star is that in this particular case you can have 0 characters or any number of characters following big D small o. So if you have a directory that's just a do, suppose I make a directory. You can make a directory by using the command called mkdir do. I'll make a directory called do which is empty. There's nothing in it. If I type lsdo star, and then it's gonna list the downloads do because it's empty, so there's nothing in it. It's empty. And then documents. If you in this case if you do do and then follow by 7 question marks, then it's just gonna list the download documents and downloads without listing the content of do, the empty directory that I just created. So the star and the question marks are what we call the wildcard. Now let's look at how we can navigate through the file system by using cd or change directory. So we're going to look at several commands that will help us to navigate through the file system. We have looked at the AOS. It's going to list the directory and files in the current working directory. So if you want to find out what's actually the path for your current directory, you can always type pwd or present working directory, and then it's going to show you the absolute path for your current working directory. So on a Linux, Unix, or a Mac operating system, you see the path, the absolute path that always starts with a slash. This is called a slash. This is actually quite different from the Windows uh, system or PC, where you actually use the backslash that goes from the upper left to lower right. On a Linux, Unix, or Mac operating system, the path is specified using the the names of the folders are separated using the slash. So it's so the slash itself is also a path. It's actually telling you it's the root path. So if you do ls slash, then it's gonna list the directories under the root directory, the files on the files and folders under the root directory. So if you do ls slash, then it's gonna list all the different folders under the root directory. And as you can see, the home directory that I am my home account is actually residing is under the home directory. So if I want to do ls home, it's gonna list my home account, my home directory, and another directory lost and found. So if you would like to change to a different directory, suppose I would like to change to the root directory, you can type just the cd and then followed by the directory name. In this case, it's just the root. And then I can do ls. If I type pwd, the present working directory, then it's just the root. If I want to go back to my home directory, there are several ways of doing that. You can just type cd, and then, as you can see, this symbol has changed from the slash, which is the root directory, to my home directory, which is just the wiggle, the shorthand for my home directory. If I go back to the root directory, there's another way for you to go back to the home directory. That's just the cd wiggle. I was telling you wiggle is the shorthand for representing your home directory. So if you do cd wiggle, then you go back to your home directory directly. Let's go back to the root directory again. And there's still a third way for you to go to the home directory. That's by using an environment variable that starts with a dollar sign and then home, or capital case home. So any kind of environment variable that starts with a dollar sign is actually representing a particular string. So if you do cd dollar sign capitalized home, and then it will take you back to your home directory. And this home environment variable is actually a particular string. If you want to see its content, you can do echo home, and then it's going to display what's actually the string inside of this environment variable home. And by doing cd dollar sign home, effectively you are meaning effectively it actually just means cd home togen. It's equivalent. Now let's go back to some subdirectory under the root. But instead of going to the root first, I want to go directly to that subdirectory under root. Suppose I want to go to the a directory that I have. I don't really know what that name is, what its name is. So what I can do is to just use the tab key. I press the tab key once and then tab again, and then it's gonna list all the directories and the files underneath the root actually. And then it's gonna go back to the prompt with the letters that you have typed already repeated. So at this stage, you can sort of look through all the subdirectories or folders underneath the root and pick one that you might want to go into. Suppose I want to go into this particular directory, user. So I'll type user. But I would like to go to a subdirectory underneath the user, and I have no idea what the name of that. I don't really know exactly what that name actually is. So I'll type the first letter. I know it starts with the letter L, for example. And then I'll just type tab again. Then it's going to list all the subdirectories or files that starts with L. And then if I want to go to at this stage you can pick a directory that you want to go to, for example local. You can always use a tab to complete it, to complete the folder or file name without typing the complete folder or file name. Now I can do an ls, for example, and it's gonna list all the folders and files underneath user local. And suppose I want to go back to my home directory now. I can just type cd. Now let's look at another capability. Suppose I want to go back to user local again, which is the directory that I was in. But now I'm in my home directory now. If I want to go back to the previous directory that I was in, I can do cd and then followed by dash, just the minus sign, and then it's gonna go to the previous directory that I was in. So we talked about several shortcuts. One is the wiggle, and if you do cd wiggle, it's gonna take you to the home directory. And then if you do cd dash, it's gonna take you to the previous directory that you were in. Now let's go back to my home directory. Under the Linux operating system, there's always two ways to specify the location of a folder or file. One is called the absolute path. If you do type pwd, it's going to display the absolute path of my home directory. And there's also another way of navigating. That's by using the relative path. In this kind of way, for navigating, you have to use the dot and the dot dot. These two types of directories or hidden directories. So if you type cd dot dot, it's gonna go to the parent directory, which is just the root home. And then if you want to go one more level, you can just do dot dot again, and then now you're under the home the root directory. And there's also another way for you to specify what this relative path is relative to. The dot dot allows you to go to the parent directory, and there's also another environment variable that's called a cd path. If you do echo cd path, for now there's nothing specified in it. So what I'm going to do is that I'm going to export cd path equals to user. So now if I echo cd path, it's going to display user. So now if I want to do cd, and then I type a file name, a folder name, suppose local, then what exactly is it going to do? It's going to go to user local. As you can see, it's actually displaying the directory it's actually switching to. So if you have specified the environment variable that's called a cd path, then if you do a cd followed by the name of directory, then it's going to switch to a subdirectory underneath the directory that's specified inside of the cd path environment variable. And cd is basically the most basic way for you to actually navigate through the file system. Now, once we have the basic means for navigating through the file system, we might want to sort of take a look at the entire hierarchy of the Linux file system. What I was telling you is that it's a nested hierarchical structure. So folders can contain folders in the files, and then subfolders can contain other subfolders. So it's a nested hierarchy. Everything starts from the root. So the root is at the topmost level. But if you would like to have a detailed explanation about the entire file system hierarchy, what you can do is to in the terminal what you can do is to type man HIER higher, and then it's going to give you a very detailed explanation about the entire file system hierarchy. And it's basically inside of the manual page, and you can read through it. So some of the most important subdirectories on the root are listed at the beginning of the manual. So basically the slash represent the root directory. This is where the whole tree starts. It's telling you it's the whole tree starts. And then slash bin, it's a directory contains executable programs. Those executables is one important component of the Linux command line. Actually, the command line is basically composed of lots of commands, and those commands have options, have lots of options actually, and some of the commands are stored underneath slash bin. And for example, some of the commands that we have looked at, for example, ls, cd, and uh, including many other system-wide commands. And then boot contains static files for the bootloader. So during the boot sequence, it's gonna read those files. And then device dev is a device, contain lots of device files, those physical devices. So under a Linux or Unix system, everything is a file actually. It represents everything as the keyboard, the mouse, or any kind of USB device are represented as a file. And then the disk is represented as a file. Everything is represented as a file, but the kind of operations that you can apply on different kinds of files or different kinds of devices are different. And then etc, what we have looked at, we have actually looked at the etc before in previous videos when we try to specify, for example, fs tab, what kind of file system you want to load, what kind of disk partitions you want to load during the boot sequence, that kind of configuration files. So here it's telling you it contains configuration files which are local to the machine. And some larger software packages like X11. X11 is basically the windowing system. It gives you the very pretty desktop environment, that kind of thing. Can have their own subdirectories below etc. So etc contains the configuration files both for the systems and for some large software packages. And there's a bunch of subdirectories underneath etc. If you would like to sort of study them, you can. This is a good entry point. This manual page is a good entry point for you to look at them. And then home on machines with home directory for users. So home is contains all the home directories for all the different users on this particular machine. So for this machine, there's just one user, that's myself. But on many of the shared cluster environment or shared Linux environment, underneath home, it could contain lots of folders, lots of home directories for every user on that system. And then lib, it's a directory for containing all the shared libraries. So all of the commands, except the commands underneath bin, the commands underneath bin are usually sort of statically linked, so it doesn't use shared libraries. But everything else, every other kind of executables or commands has to use some kind of shared library. Those shared libraries are system-wide. So lib actually contains those shared libraries. So when you run those commands, those commands are going to call subroutines that's stored in those libraries, and those libraries are actually stored underneath /lib. Media is a directory for you to mount. Those are mount points for removable media, such as CD, DVD, or USB sticks. This is actually quite a useful directory to look into, actually. So if you have a CD or USB sticks that's mounted, those mount points are likely to be underneath media. And MNT is sort of the directory for the conventional mount point, a temporary mounted file system. So when we were doing the Gluster file system, it was mounted underneath MNT actually. So OPT is for optional add-on packages. PROC is a very interesting directory. So the stuff that's used, this is a dynamic directory actually. It's telling you that this is a mount point for the PROC file system, which provides information about the running processes and the kernel. This pseudo file system is described in more details in PROC, so you can just type man PROC to look into the details of PROC. This is a dynamic file system, so it's not static. And the stuff that's inside of the PROC directory will dynamically change based on your system status. So it's the stuff that's inside of the PROC is actually derived from the memory of the machine. It it's gonna tell you many useful information about the health, the status of the entire system during the during the operation. So you can basically find, for example, you can find the CPU information underneath PROC, and you can find memory information, how the memory is actually changing during the operation, during the operation of the entire operating system. So this slash root is different from slash actually. So slash root is a directory usually that's the home directory for the root user. Sometimes you don't have it if you don't use a root user. If you don't have a root user on a system, then you don't have it. And then sbin is another very important directory for containing lots of commands used by the command line system. So it holds commands needed to boot the system, but which are usually not executed by normal users. So system administrators use those commands inside of sbin quite often, but not like normal users. Normal users usually use the binaries, use the executables inside of /bin. Server, temp, as you can imagine, it's for storing temporary files. And then user, we looked at the user. It's usually mounted from a separate partition. It should hold only shareable, read-only data, so that it can be mounted by various machines running Linux. So basically, it gives you lots of very detailed explanation about each of the subdirectories underneath the root. And if you are curious, you can always open this particular manual page by type man HIER in the command line, and then it's gonna tell you what those directories are for. Now let's try to create some files. We'll try to create some empty files first using a command that's called touch. So inside the terminal, I'll just type touch. I'm gonna generate 3 empty files. They are named as ABC1, ABC2, and ABC3. So I'm going to generate the 3 empty files under my home directory. If I want to list them, I can do lsl. If I want to do a long list, ABC. Don't forget about the wildcard. I can use just the question mark wildcard to list all 3 of those empty files. And as you can see, the size of each of the file, for now, it's 0. And in a later video, we'll talk about how to use editors and put stuff into these 3 files. And we can just, for now, let's just use the echo command. We can echo a sequence of text. Let's say test 1, 2, 3, 1, 2, 3. Or echo this particular sequence, and then echo them into a particular. If I just type echo, and then it's just going to repeat the sequence of string on the screen. But if I use the larger than sign, which is actually a redirection sign, and then I can put the sequence of text into one of the empty files, and then I can just do ABC1, for suppose. Now if I do lsl ABC question mark, and then you'll see ABC1 actually has a non-zero size now, so it means it has stuff in it. For now, let's just we haven't talked about how to display the content of a particular text file, but let me show you one of the commands for doing that is called cat. So if you want to take a look at the content of the text file, you can just do cat abc1, and then it's just going to display the content of it. We'll look at the other commands for displaying the content, including the cat command in more detail later, in a later video. Now suppose I want to create some empty files in a specific directory. Suppose I want to touch ABC4, ABC in a specific directory. Suppose I want to create an empty file in a directory that's called temp, and then underneath test, and then I want to do ABC4, for example. Let's see what's going to happen. So So it's gonna tell me that temp test abc4 no such file or directory. The reason that it's giving me this error message is that this particular directory temp test does not exist yet. So if you want to create an empty file underneath this non-existent directory, it's going to give you an error message. So how do you actually deal with that? You can create this particular directory, right? You can create a directory first, and then you can put an empty file in it. I was showing you how to make a directory uh, in a previous video, and it's called mkdir. It's just a make directory. So if you would like to make a directory in the current directory, underneath the current directory, you can type this thing. So you want to make a temp test this underneath the current directory, and let's see what's going to happen. So it will create this particular directory for me, and then if you actually take a look at my home directory, you'll be able to see here's the 3 files that I have just created: A, B, C's 1, 2, and 3, and then there's a temp directory. And then underneath the temp directory, there's supposed to be a test directory. There's a test directory, subdirectory in it. And now if I do touch temp test abc4, then it's gonna put an empty file called abc4 underneath the temp test. So if I want to do lsl temp test, it's gonna show me abc4 with the size of 0. So if I want to remove those files, I have created a bunch of empty files. Suppose I want to remove them. Suppose I want to remove abc1, for example, or abc2. I can use the rm command. The rm command represents remove. So I'm going to do abc2. I'm going to delete the empty file abc2. And after you type in this command, it's actually asking you remove regular empty file this abc2. It's actually trying to confirm with you, do you really want to remove this file? Have you made up your mind to remove this file? At this point, you can type either Y, yes, to accept removal, or type N to quit removal. So I'll type yes. I'm going to remove that particular file, and as you can see, abc2 disappeared. So this rm, the behavior of this rm command is not sort of the default behavior of the rm tool that's in the command line system. So if you do type rm, you're going to see that this rm is actually aliased to rm-i. So -i means interactive. So every time you want to delete something, it's going to ask you, do you really want to delete it? So give you a second chance to think about it. Because the rm command is not like the trash can in the Windows desktop or Mac desktop, where you can recover a file later on if you decide not to remove it. Right? You can go to the trash can and recover the deleted file. In the Linux command line, the rm command doesn't actually give you that kind of capability. If you do rm and delete something, you cannot recover it unless you go to some professional data recovery service with lots of money. So it provides you this kind of option -i interactive to confirm with you, give you a second chance to think about it. Do you really want to delete it? And the default behavior is without this -i actually, without the sort of. But if you actually define alias with the -i included into every time you issue the command rm, it's gonna call rm-i actually. So now suppose I want to delete the rest of the files on my home directory, delete abc1 and abc3. So what am I going to do? I'm going to, if you want to remove the alias, if you don't want to use the alias at all, you can type a command called unalias and then rm followed by rm. And now if you do type rm, it's gonna tell you that rm is hashed being rm. Now it has gone back to the default behavior. That's the command line rm without the -i. So now if you do rm, say abc3, then it's not going to ask you, and abc3 is just going to disappear right away. So I'm still going to go back to the aliased version. So I'll still define alias rm equals to rm-i. So I'm still going to ask him to ask me. So now let's try to delete the last file. That's abc1. So if I issue this particular command, if I execute this command, it's going to ask me if I really want to delete that file. So if I am sure about deleting this particular file, and I don't want to type y or n, yes or no, I can precede rm command with a backslash. So if you do a backslash, it's going to go back to the unaliased version of the rm. And then it's not going to ask me, it's not going to confirm with me if I really want to delete this particular file. So abc1 has disappeared. Now we have abc3 or abc4 that's underneath temp test. So how am I gonna delete that particular file? Suppose I want to delete the entire directory temp. Suppose I want to delete the entire directory temp with abc1 in it, abc4 inside of it. So if I do rm temp, it's telling me cannot remove temp because it's a directory. So how do you actually remove a directory? You can remove a directory by using -r. In this particular case, R actually means recursive. It doesn't mean reverse or something. It means recursive. So it's gonna go into the temp and then delete everything that's inside of it. If the temp has subdirectories, it's gonna descend into the subdirectory and delete everything inside of the subdirectory. So if you do rm temp, and then it's gonna ask you, do you want to descend into directory temp? I say yes. And then temp has a subdirectory called test. It's asking me again, do I want to descend into directory temp test? I say yes. And then it's asking me, do I want to remove the regular file temp test abc4? I say yes. And then it's asking me if I want to remove directory temp test. I say yes. And then remove directory temp finally. So temp has disappeared. So in order to actually remove that particular directory, I have to type lots of yes or no. Now let's try to recreate the directory structure that we were using. We had a temp directory under the current directory, and then there's a test subdirectory inside of temp, and then the abc4 regular file is inside of the test subdirectory. So now let's try to. Last time we were making the test directory inside the temp by using mkdir temp test. But now let's see what's going to happen. Because now we have deleted the temp directory. Let's see what's going to happen if I issue this particular command. And then it's going to tell me cannot create directory temp test, no such file directory. If I do an ls, you don't see a temp here. You don't see a temp here. So the correct way for you to do that is to mkdir temp first, and then followed by mkdir test, temp test. And this way you're going to get a temp, and inside the temp you're gonna get test. But this is quite a tedious way for creating a nested directory. So what I'm gonna do is that I'll use the -p. I'm gonna use the -p. I'm gonna use the -p to try to create a new structure, new directory structures. Oh, so first let me remove the temp directory structure first. I'm going to explain this particular command later on. These two flags are F later on. But let's try to make the directory by using a -p flag. Still, I don't have for now. I don't have the temp directory, right? But if I do mkdir-p temp test, it's going to automatically create the parent directories for test also. So dash p actually represents parents. So it's going to ask you, I'm going to create the test as a subdirectory of parent temp, and I'm going to create the temp directory if it does not exist yet. And this time it's going to give me temp with a test subdirectory. And you can actually do this dash p for any level of nesting. So you can dash p. Suppose I want to do temp test, and then I want to do test 1, test 2, test 3. Remember, you don't have test 1, test 2, and test 3 underneath test. These subdirectories are all nested, but it's gonna create all those nested structures for you. So if you look at test, if you look at temp, you have test. If you look at test, you have test 1 inside it. You have test 1. You have test 2 inside it. Now you have test 3. So all those directory structures are created just with a dash p. So suppose I want to generate an empty file that's underneath test 3, for example. For now, that I can do that just by typing this command, and then abc4. Now if I look into this particular file, I'll do a long listing, then it's going to display as an empty file. Now let's look at how to delete this entire directory structure, nested directory hierarchy, by using rm -r and then f. Last time we looked at the -r command. The -r command allows you to delete the entire directory structure, but it's going to ask you if you want to descend into the directory, if you really want to delete the particular file. So it's quite a tedious way for interacting with the command line. And it provides an option called force, f-f. So -f means force. So if you do -f, then it's gonna just skip all the asking, all the confirmation with you, and it's just gonna delete the whole thing entirely without asking you any questions. And of course, you can combine -r, which is recursive, and -f together, and then it's just gonna delete the entire directory structure, and you won't be able to see the temp and any of the subdirectories underneath it, or nested subdirectories underneath it. So if you would like to delete multiple files in just one command, you can also use the wildcard with the rm command. So suppose I'm gonna recreate my 3 files, abc1, abc2, and abc3. I'm recreating 3 empty files in my home directory now. So if I want to remove all 3 files in just one command, I can use abc, the wildcard, question mark, with the wildcard. Or you can do abc with a star. So the question mark is gonna fix the file name to be abc with 1 character following. But if you do abc star, it's gonna be 1 or 0 or any characters following abc. So if I do abc star, it's just gonna delete all 3 files together. If I want to do a force, I want to turn off the confirmation, then it's gonna delete everything that starts with abc. So you can also combine the wildcards with rm. So the wildcards can be combined with many different commands actually. So it's actually quite useful for you to improve your efficiency. So for now, the files that we have created and deleted are all under my home directory, which is also my current directory. So suppose I'm not in my home directory. Suppose I go to the root directory. I have changed my current directory to the root directory. If you don't believe me, it's a root directory. Can I create files under the root directory? Can I create directories under the root directory? Let's give it a try. Let's try to make a directory that's called temp, and it's telling me I cannot create it because a temp already exists. If I do a listing, yes, I do see a temp. I do see a temp. That's a system temp. That's generated by the system. This particular folder. So suppose I want to do mkdir temp 1. I don't have temp 1 on my current directory, right? But it's gonna tell me permission denied because it's the by default, if you are a regular user on a particular machine, you can read and write files in your home directory, but you can only read the files that belongs to the system. The root directory actually is a system level directory. So as a regular user, you cannot really uh, write stuff into the system directory. So if you really wanna create a directory that's underneath or write stuff into a system directory, you have to follow your command with sudo mkdir and then temp1. Then it's gonna ask you for the so it's gonna ask you for password, but this password has to be the administrator level password. So for my account PoChain, I have administrator privilege. So so it's gonna ask me for the administrator privilege password. If I type in my password, it's gonna allow me to create or write stuff into my directory. And if I wanted to remove this particular directory in the system, if I do rm/rf, for example, temp1, again, it's going to tell me permission denied. So again, you have to follow sudo, proceed sudo to the command, and then it's going to allow me to delete it. So now, the files and directories that we have been creating are all under our current directory. So if I want to create something or create a file that's not under my current directory, but it's suppose I want to create an empty file under my home directory. How am I going to do that, right? What I was telling you is that the wiggle is the shorthand for your home directory. So what I can do is to touch followed by wiggle underneath ABC1, and then it's going to allow me to create a directory that's underneath an empty file that's under my home directory. If I want to look into that directory, look into my home directory, I can do ls wiggle, and then I'm going to see my file. That's ABC1 there. So if you want to create another file, but this time if we don't want to use my use the shorthand representation, I can type in the absolute path of my home directory. So this way you can actually access. You can create an empty file in my home directory by using the absolute path. So it's basically the absolute path of my home directory is just a home PoChain, and then I'm creating an empty file underneath it. So if you do ls, you have another empty file abc2 underneath it. So you can use either an absolute path or a relative path in your when creating files and directories or deleting files and directories. So suppose I want to delete those two files on my home directory. What I can do is I'm gonna use f abc with a wildcard, and then it's gonna delete all the stuff that's on the two files, the two empty files in my home directory.